Hello.
Hi.
All right, so we're going to do some automated testing, what we're doing at here in Missouri. I'm Buddy Hammond, and I'm the principal programmer there. So let's get going. So this is the agenda. I'm going to go over where our stack is, a little bit about what Cypress is, how we're doing business-driven development, how we're using code generation, how we're using data to drive our tests, how we're doing performance testing with the results of our test, and then some stats kind of follow up. So the tech stack, as was mentioned yesterday, we're a Java Spring, 3-tier system. So Oracle on the back end, jQuery on the front end, and Java in the middle. It's a single page web app. We use a lot of JUnit for the Java, and our development tool is VS Code, and we're using JRebel. If you're a Java shop and you don't use JRebel, look into it, it's amazing. So in our environment, we have different roles. We have developers, obviously management, and we have business analysts. We do not have a QA department. It's the only organization I've ever been in that doesn't have a dedicated QA department. What happens is the business analysts, they do the requirements and the specifications. They guide the developers, work with the developers, and then they create a test plan for the code that's going to be written. They then, after the development is done or as it's ongoing, they use those test plans to go through the code and verify the code is doing what it's doing. And the test plans are just in English, plain English in an Excel spreadsheet with columns telling certain conditions, which we'll see in a minute. So it's written in plain English, no special language, no Gherkin if you're familiar with BDD kind of frameworks, just whatever you would give to a human being. And this was done long before I got there. When I came here a year and a half ago, there was already spreadsheets in place. There was already people using those to validate the software. It has columns such as what a precondition might be, or what a test step would be, or what the expected results. And then it also had columns for the different environments that we have, which there's 5. Dev, MV, test, UAT, and training. And so we move our code through all those different environments over time. Is this breaking up?
No.
Oh, okay.
Sounds good, buddy.
Okay, so each row in the spreadsheet delineates what is happening, what the precondition is, what you should do, and what your expected results. And sometimes there's a lot of expected results. There's different things that can happen depending upon what you're doing, what you're interacting with. So this was given to certain users that work with the business analysts, and they would do these validations. One of the problems is the system is massive, and there's no way that we can continue doing these tests manually and keep up with all the changes, all the new development. We have close to 30 developers all in the same area, so it's huge. So this is what a spreadsheet looks like. This is an example of one. You can see on the far left, there's a test scenario, and then there's a precondition. In this case, the user has validated, selected and enter a case somewhere on the menu system. And then the test steps. And I highlighted where it says enter last name, enter first name. But you can see these are just English. There's no given, there's no ands, there's no, just plain English. And all of this code here, all these steps delineate what is to be done, and then expected results over on the far right. And that's what we started with when I first came, and I did my first full stack implementation. I was given a spreadsheet, and I figured out how to automate it and test it and showed it to my management, and they were saying, let's run with this. This looks like it's worth doing. So I'm going to show you, this is what we started with. Our intention was to not change anything in our process. It's stable, the BAs understand it, the business people understand it. It's a very well-formed waterfall in some respects, but we didn't want to introduce any new requirements or any changes. So the business analysts continue doing the specifications, the requirements, and their test cases. It's just now, these test cases become executable code. So Cypress, why, what? I've done business-driven development, automated testing in Selenium, and it's incredibly difficult. That's my past in different companies before I came here. Cypress is much different. It runs inside the browser with the web app. Now, if you are testing mobile devices and stuff, Cypress is not for that. It is only for HTML web-based applications. The framework runs on top of Node.js. If you're familiar with that, that's basically JavaScript on the command line. And it runs in the browser with the application. So in that sense, your code, your testing code has complete visibility into everything that you would see as a developer in developer tools. You have access to the elements, the page, the CSS. We can see the network requests. So when we're doing something and it's a long request or there's multiple requests, we can put in code that says, monitor this request, and when it's done, then I'll move on. So all these things about, do I wait 1 second, 3 seconds, I'm looking for something on the screen? No, you have complete visibility, just like a developer does when they're interacting with the page. You can get the elements through the ID, through a CSS path, the next path, whatever you want to do. You are in the browser, working right alongside, you'll see that in a moment. And Cypress takes care of a lot of this stuff. For instance, if we have a long menu and it scrolls off the page, right, can't see it. But when I tell Cypress, hey, click that menu, it knows it's down there, it'll scroll it up and click it for me. So a lot of complexity you have to deal with Selenium was my response, my experience was, all that kind of disappears. Cypress knows because it's in the browser, it can see everything. One of the beautiful things about Cypress is it has this thing, time travel, and I'll show you that in a minute. I've never seen it before in a tool like this, but as we go through our development experience as a Cypress developer, and we have a failure, everything that we just got done doing, every single action that occurred with that browser is recorded. And you can go back in time and see exactly the state of the browser in connection with whatever code you're doing. It's really amazing. So from a developer's perspective of writing the automated test, it's just amazing to be able to go back and see, I missed this piece right here. There we go. They call that time travel. So this is what it looks like in the browser. On the left-hand side in the black, that is the English of the code that we're running. So that code that was in the spreadsheet ends up as English sentences of, you're going to do this, and then expect that. That's in the left-hand side. Now that is not code, that is just the statements that we're going to be doing because we're running in a BDD type of style, so it's in English. On the right-hand side is the application under test. That's our application. In the bottom is the debugger, the developer tool. Okay, so just exactly like the developer goes into. And I have a breakpoint on my Cypress code. My Cypress code is running inside the browser as JavaScript. And you can see I'm in the method called enter last name. You can't see that up here. But earlier I showed you a spreadsheet where I had a test step that said enter last name. We code generate a lot of code, but basically I take the information in that spreadsheet and they become function names. You know, just do snake case, lowercase, uppercase, put it all together. And now you have a function in JavaScript. So when our developers are given the spreadsheet, they have code all generated for them, and all the functions, all those steps end up being functions. They get called one after the other, and they go in and implement what does it mean to do enter last name. Well, get this field using CSS, get the ID, last name, put a value in the field, and then move on. So you can see here we have a breakpoint on the code in the blue line, and it's getting ready to take the element that's in the page, and you can see that I have a mouse over it, and so the data that I'm working with shows the JSON, and it shows the values of what I'm looking at. So you're in, just if you're a developer in web app, this should feel very comfortable because you're writing the browser, you're writing the Chrome developer tools or Edge, same thing, and you're able to interact with the page and investigate everything. So that is the integrated environment where Cypress is running in the browser with your application. You have full visibility. So This is time travel. Watch what this is doing. This is the test that was completed. The mouse is moving on the left, and you can see the browser go back in time. As I move the mouse over a statement, the browser goes back and it shows you at that point in time what was going on. So you can see, this is not a running test, this is after the test. I can go back and look and see exactly, so when a test fails, I can go back and see what was the data, what was going on. It's astonishing. Now, there's one little side note about that. If it's a really long running test, it's a lot of memory because it's snapshotting every single action. And sometimes it blows up. But otherwise, it works pretty good. So that's time travel, and that's a Cypress thing, okay? So when we run our Cypress, everything is automated. We have scripts that when we say go run against the dev environment, it figures out what release are we in on the dev environment. It goes to the dev website and it looks at the bottom left side and it says we're on 10.49. So our source code is tied to the release code. So I pull down 1049 Cypress code and it's all automated, pulls down the code, builds everything, imports everything, runs all the tests, builds all the reports, sends out emails, and just does all that. Now we do that for all these different environments. We deploy to dev twice a day, and we run it in all the other environments that we have. Out of that, we come up with a report. This is one of the reports, and it gives us an idea if there was any failures. If you scroll down through the report, you can see all the scenarios. And in this case, there was a failure, and the failure, you can go to the step and find exactly what step it failed, and there's a screenshot. We didn't have to code for any of this. We just had to wire it up and say, here, go make a report, and it just puts it all together for us. So very low hanging fruit, very good quality reports. And when they fail, we can go in and see exactly what happened. Sometimes not exactly, but at least you get an idea. Yeah?
So how large a library of these screen capture tests do you maintain?
We're not doing screen capture tests. We're doing automated live testing. When they fail, there's a screen capture of the failure.
Mouse capture. Because
We're not.
You're not recording this?
No, we don't record it.
Okay.
No. So, code generation, I mentioned it before. We wanted to make it to where those spreadsheets could be the source of truth. Developers just don't start with an empty plate, they start with a spreadsheet. They run a process I wrote, and it generates all the different classes that are required to run in a Cucumber framework. But those things are one-to-one relationships. What's in that spreadsheet and what's in these classes are one-to-one mapping. And the only thing that the developers have to worry about is how do I implement the action? And you can see here there's a stub. When I generate these out, they're a function, but they're stubbed out. I don't know how to implement inner last name. I don't know what that means. But the developer has to go to the page, go to the field, get access to it. So we do code generation, and if the business analyst comes back later and says, this step changed, or you need to insert something here, we do not touch the code. We change the spreadsheet and we regenerate. And that regeneration does not delete anything that was already coded. It just generates a null file and says, here, you need to add this. And through looking at some of the tools we have, you can figure out what thing fell away or got deleted. So it's all code generation, and the document of truth is the spreadsheet. Developers do not maintain the spreadsheet. In fact, we can't even write the spreadsheets. Business writes the spreadsheet. So this is all business driven. The test, the steps, the expectations, everything is done by the business. We as developers just implement it. And that way, everybody has their part, but it's also very business driven. We're not like going in and saying, hey, I think this is a really cool element and some kind of component, and I'm going to play around with that and write a bunch of tests. No, if the business says that there's supposed to be a test, that's what we do. We also did not boil the ocean. Our system is huge. I mean, we're only doing like 35% of the menu options in Cypress so far, and our test runs over an hour and a half, just as fast as you can go, and it still takes an hour and a half. It's huge, and we're going wide. And we made a conscious decision that we're not going to try to get every single kind of scenario, and we're not looking at Did the UI change? We don't care about, we do care, but this code does not care about the aesthetics of the page. It's process, functional. Is it working as designed? We want to know if a developer made a code change somewhere, did they break something somewhere else? Happens all the time. You wouldn't believe it. I believe it, I do it myself. So we run these scripts every day in all these environments, and then in our development, each of the developers are given a feature. When they're given that feature, they make a branch, they pull off the main core branch, and in their feature branch, they do all their code changes. When they're done, they do a pull request. That pull request now, we use Bitbucket, and so Cypress is not just a testing tool. I took Cypress and used it to go look at all these pull requests. They're just in a web page, right? Cypress is perfect for going to a web page and seeing anything I want to do. It's like a scraper if you want to use it like that, so I do. So I go through all of those spreadsheets, I go through the website and see all the pull requests. I have 6 machines, and I go through these machines. Each machine goes in about every 3 minutes and says, is there another pull request to process? It finds that pull request, one that doesn't have we have a reviewer named Cypress. And if that pull request doesn't have a Cypress reviewer to it, we add it in. Cypress adds itself in as a reviewer, and then it falls out, and then the next step of the process says, hey, pull down our code, compile the code, build the code, do all the JUnit tests, and then we have on each server that's running these PRs, we have 5 different Tomcat servers, one for each of our environments because they all have different configurations to go to different databases. And then we run the code in the particular environment, not just dev. If you're doing a cherry pick and you're going to go to the UAT environment, we will test it against the UAT environment. And it's all automated. One command and it just does everything. When it's done, it sends out the reports to the developer. It goes back into the pull request using Cypress to go in, navigate, go to the pull request, go to the approve or disapprove, and complete it. So the people that are doing the merges don't merge until Cypress is done testing. If there's a failure, the team that is monitoring Cypress will go in and say, well, was this just a hiccup? They'll rerun the failed test because we know exactly what tests failed. If it failed again, then we get in touch with the developer, say, hey, what's going on? And we work with them to figure out what's going on. Otherwise, it's all automated, test run, it's successful, PRs are approved, away they go. Yes, sir.
Do you have a code review process? And if
Yes.
so, do you do the automated test before or after?
Yeah,
code
before.
review?
Yeah, they don't even want to look at the code if they can't pass the test. So that's kind of it. So again, the code generation uses the spreadsheets. It's considered the record of truth. We generate or regenerate the code. We use a BDD framework that is called Cucumber. The developer implements the empty functions, and any change to a business test results or requires a change to the spreadsheet and a regeneration of the code. So that's been very stable, no problems with that. So the scripts do not know the data. The scripts know log in, but they have no idea what environment they're logging in. So all this stuff is abstracted out. When they're coming in, everything is done from scratch. We do not use any. The only data that we're using is the lawyers and the judges. Everything else is, every test builds everything. If there's a defendant, we build a defendant. If there's a civil case, a criminal case, it's all built from the ground up. If we're doing finance, we have to build all that up, make all the charges, do the plea, find the charges, do the fines, pay it out. Everything is done from scratch so that there's no possibility that somebody else messing around the system happened to change a case that we were trying to use to do testing. No. Bottom up, nothing. So what we have to do is we have a thing what we call is fixtures. So it's just a JSON file, but it tells us the data that is pertinent to the environment we're in for this particular test. For instance, when we are in a different environment, we're using a different court. In one place we're using Carter, another place we're using Franklin. We're in the different courts of Missouri. So you can't take your test and expect to run it exactly in another court if you're using the wrong data. So each test has multiple files, depending upon what environment it's in, it'll use the data for that environment. So one of the other things that we've done, and this is more of a recent thing, but one of our business analysts was looking at this and he said, wait a minute, this is pretty cool. He said, your scripts, your classes, your service classes. So one of the things, let's kind of back up for a second. When we first go through a process, it's very detailed, right? Inner last name, inner first name, inner city, get this, very detailed. But later, when a business analyst is saying, well, I want you to create a criminal case, we don't want them to go through all that detail. Just create a criminal case, give it this charge, use this, plea, and have this fine. And so we made service classes where the developer makes one call to an API, and all of that work in Cypress gets done. You can watch the Cypress go through and build a client, build a civil case, build everything out, everything. So we have the ability to do massive amount of Cypress functionality, testing the service with very little code. And so the developer said, the BA said, well, look, you have this data already abstracted out, but you're using kind of the same data. Every time you're running dev, you're using these fields in dev. They're the same fields, but you're randomizing and creating a case from scratch. So that's good. Well, what if we took another approach and said, take that data and put that data in a big spreadsheet? So now you have all kinds of, same Carter County, but all kinds of different codes and charges and fines and run all of that data through. So that was something we did recently, and it just, we do everything from soup to nuts. We got everything through finance and charges and garnishment and everything. So being able to use a lot of data to drive these tests just bring a whole new perspective on doing the testing, because it is data driven, right? I mean, all this, there's so much data that controls all these charges and what happens when this happens. That all is in the database too. So going through with a massive database and driving it that way was a different approach. So in that point here, using data to generate the test. So I don't want to get into the weeds here, but the main idea is if you can handle one set of data pretty easy, why not handle 100 of them? 100 different variations and permutations and combinations. And guess what? We found problems with the system. So here's our 5 environments: dev, MV, test, UAT, training. And again, the actions is the thing that says enter last name, enter first name. But when it comes in, it says enter the charge. It doesn't know what charge to put in any of those environments. Again, that's in the JSON file that says for the MV environment, the charge is going to be M15, 25, whatever. And then this is that large data set. So what we have here is a massive spreadsheet, and we said, here's a service that will process that spreadsheet, and that service just turns around and it's calling all these different actions. This thing takes hours and hours to run. But at the end of it, we have a real sense that the system doesn't have data errors or consistency errors or logic errors related to data, so to speak. So one of the things that we do is when you're running, are you guys, do people know what a HAR file is? HTTP archive file? Okay, when you're running in Edge, we run into Edge now, or Chrome. They're both based on Chromium. In the developer tools, there is a way to see every network request, every single request, every data that's related to it, and all the response back. And you can, in the recording, in the tool, in the Chrome tool, you can say record this activity, and then you can save it off as a file. It's a big JSON file, just a lot of text. But we're running this automated. So we were able to find a tool that is part of our test. It's just a library, and whenever we start our test or scenario, we start that HAR file recording, and at the end of it, we shut it down. And then we process that HAR file and remove the login, because the login, we use ready passwords right there, so we remove all that, and we save all that, but that gives us to what? 2 minutes? I thought I had half an hour.
Yeah, you're at,
You're kidding me.
No.
Okay, sorry. I lost track of time. Okay, so we use that HAR file, so moving on. So we take that HAR file and we use a tool called K6, and we process this HAR file and clean it up so that we can say, do a request, and then get the response back and take that response and let's now use that dynamic case ID that came back for the rest of this stuff. So we were able to take the HAR file with the case 6, which is written in Go, and we were able to do like soak test, load test, all that kind of stuff. Here we did like 9 million HTTP requests. We ran it for 5 hours and 15 minutes. And because we're Java, we're really interested in the garbage collection. And here's your typical sawtooth. We were never able to do this before. To put a load on our Java environment and see the sawtooth, see the garbage collection, see the stability. So because of Cypress, with the HAR file, with K6, we were able to do that. Here's our stat. Thank you for the 2 minutes, because I'm almost out of that too. We got 3 full-time developers that know how to do full stack with Cypress. We have 5 of those. We have 3 people that are doing full-time Cypress, me and 2 other folks. We have about 96 scenarios now. We do the 5 environments. We're doing about 200 pull requests a month, testing them. And the average runtime, when I wrote this, was 1 hour and 10 minutes. We're up to about 1 hour and 21 now, and it's growing. And we use 6 servers to do the PRs to handle all those. So, made it.